In this video, you're going to learn a product rule for differentiation. So remember that in mathematics, product means multiply. So this is a rule that helps us differentiate functions written as two functions being multiplied together. So you can see in our example problems here, which we're going to work in a moment, that the overall function is being written as two individual functions being multiplied together. And this is a scenario you've got to look out for to use the product rule. And notice that the individual functions themselves can be different types of function. They don't have to be any particular type. As long as the overall function is being written as a product of functions, then you can use the product rule. And you just have to use whatever rule you need to use to differentiate the individual functions, as we'll see later on. So let's start by considering what the rule itself looks like, and then we'll get into these example problems. So there's a couple of different ways to write this rule. I'm going to show you both ways, and then you can decide which one works best for you. So if you take two functions which are written as a product, so let's say we've got an f of x function, and that's been multiplied to some other function g of x, and we want to differentiate this. So we can write that as the derivative with respect to x of that product. So that's the scenario we're looking out for in the case where we can use the product rule. So that is how these are all written, where this would be your f function and this would be your g, and this is your f and this is your g. Don't worry about the fact that the overall function is also called f. So these are written as two functions, and this is written as two functions being multiplied together. So the product rule says in this scenario you take the derivative by this little sort of formula here, which is to leave the first function alone, so just f of x, multiply that to the derivative of the second, so it's f of x g prime of x. Then we're going to add to that the second function, g of x, multiplied to the derivative of the first. So you just basically have to learn that rule. And there's different ways to learn it. I quite like to just think of it as the first times the derivative of the second plus the second times the derivative of the first. So that's one of the ways we can write the product rule. Some people prefer to write it using different letters. So for example, a common method would be a u and a v. Maybe just to separate it out from the fact that sometimes the overall function which you're trying to differentiate is also written as f or g. But it's up to you, whichever method works. Ultimately, the method is the same both ways. So in this scenario here, it would be u times v prime plus v times u prime. So again, that's just saying the first function multiplied to the derivative of the second function plus the second function multiplied to the derivative of the first function. So these two different ways of writing the product rule are the same, just basically using different letters. Sometimes one of these will fit a student's eye better than the other, so whichever of those you want to use is absolutely fine. But the implementation of the rule, using the rule, is the same regardless. Okay, so that's the theory, that's what the rule looks like. You do just need to learn it. Some people like this version because they can just say in their heads u v prime plus v u prime. If that helps you, that's great. Whichever method you need to use to learn the rule. Let's go ahead and try and apply it. So here we've got our f of x function, which is written as a product of the functions 2x and x squared plus 2. If you want to put this in a bracket, I mean, you don't need a bracket, but it might help you to explicitly see that these are two separate functions being multiplied together. So this is definitely a candidate to use the product rule. What does our rule say? It says leave the first function alone. Okay, so we're not doing anything with that first function, you're just kind of leaving it alone. And you can put this in a bracket if you wish. I personally like to put all four terms in a bracket for the first line of working. I find that keeps it nice and compact and neat. So leaving that first one alone, taking the derivative of the second, so that's going to be like your g prime of x. The derivative of x squared plus 2 using the power rule is 2x. Okay, and then we're going to add to that the second function, x squared plus 2 times the derivative of the first. The derivative of 2x is 2, so just like that. So notice that to use the product rule, you need to use the power rule as well. You still need to be able to do that, but if you're watching this video and you're trying to figure out the product rule, you probably already know the power rule, so that's fine. So that's our first line of working. On that first line of working, you're always going to have four terms, and everything after that is really nothing to do with differentiation. It's now just simplifying using algebraic techniques. So multiplying these together to get a 4x squared, multiplying that 2 into the bracket here to get a 2x squared plus 4, and then just tidying these up by bringing these x squared terms together to get 6x squared plus 4, and that's the final answer. So really the differentiation all takes place on the first line of working, and then usually in these questions, because this tends to be quite a messy expression, there usually will be 2 or 3 lines of simplifying and algebra after you take the derivative. Okay, let's just scoot straight on to the second one. Similar, but slightly more, more terms, I guess, to deal with. Of course, I should have written in here, which is a terrible mistake to make, that this is our derivative at this point. This is our f prime of x. And here, again, this is going to be our f prime of x. So is it a candidate to use a product rule? Yes, because we've got our overall function written as a product of 2 functions, so we can do the same thing. Just going to leave the first function alone, multiply that to the derivative of the second. The derivative of x squared, x to the 4 minus 2 is 4x cubed, using, again, the power rule. And we're going to add to that the second function, being sort of left alone, times the derivative of the first. The derivative of 3x plus 2 is 3. So there we have it. So this line of work in here, that's just the equivalent of this guy here or this guy here. Oops, put that back the way it was. And then it's just going to be algebra. So then it's just quickly tidying everything up. So multiplying that 4x cubed into this bracket to get 12x to the power of 4 plus 8x cubed. Multiplying the 3 into this bracket, so 3x to the power of 4 minus 6, and then just tidying this up. So that's going to give us 15x to the power of 4 plus 8x cubed minus 6. So that part should be trivial. I'm sure your algebra is more than good enough to do this part. It's really just getting from here to here that is the product rule itself. One really important thing to note with the product rule, super important, is that you might have already seen expressions like this and being asked to differentiate them before you knew about the product rule, when you only knew about the power rule, and you can do that by multiplying out the bracket. So if, for example, you'd never heard of the product rule and you still wanted to differentiate this function here, you could multiply out the bracket to get 2x cubed plus 4x. This is now in the form to use the power rule without using the product rule. And if you use the power rule on that, the derivative of 2x cubed is 6x squared, the derivative of 4x is 4, so you would get the same result, and arguably you would get the same result more quickly than using the product rule. So you don't always have to use the product rule if the function is written as a product of functions. You do sometimes have the option to use indices rules, like I've done here, to expand the bracket, and then just use normal power rule. The same would apply here. In this case, it's maybe more debatable about which rule is going to be best to use, because it would take quite an effort to multiply out these brackets, and then you would have to differentiate after that. So these two cases, there's an argument for using just the power rule and some indices rules. But when you get up to cases where, for example, the bracket might have a higher power on it, or cases here where there's no option to multiply out brackets, then you're forced to use a product rule. But it's really important to know that there are scenarios where potentially you could bypass the product rule and still just use the power rule, and it might actually be more efficient to do so. But in a case like this, that's definitely not going to be a great idea, because to expand that bracket would take a long time, and then you'd need to multiply the 3x into the bracket. It's just going to get really messy. So we're going to go with the product rule for this one. So it's set up to use a product rule. We've got the product of 2 functions here, so it's fine. We can make that quick check. We're definitely good to use the rule, and it's really important to make that check, because the mistake that most students make is actually not in using the rule, it's in applying the wrong rule. So we reckon we're good to go here with the product rule. So we're going to leave the first function alone. That's just going to be a 3x, like this. The second function here is a little more complex. It's a composite function. We have to use the chain rule. If you're not familiar with the chain rule at this point, then link to my other video, which explains the chain rule. The link will appear in the top corner of this video. And then figure out how to use the chain rule. The chain rule is just one of the other differentiation rules, and this format of this particular expression requires the use of the chain rule, but we're still overall using the product rule here. In fact, this is a very common setup within the product rule, where you've got to use partly the power rule and partly the chain rule. So the chain rule says that we bring the 3 in front, leave the bracket alone, take 1 off the power, and then multiply by the derivative of the bracket, which is 4, like this. And if you're not familiar with that, that's cool. You can figure that out as you go along, as you get further into differentiation. So this is the first function times the derivative of the second, and then we're just going to leave the second function, 4x plus 2 cubed, times the derivative of the first. The derivative of 3x is 3, so we just park a 3 on the end like this. So this one's quite messy, and it would be messy if you multiplied out all of the brackets as well. So it's difficult to avoid just the sheer number of terms and the messiness of the algebra in this one. So we're going to tidy this up a little. If we multiply the 3 and the 4 to get a 12, and then multiply that by the 3, we'll end up with a 36. So it's going to be 36x times the bracket 4x plus 2 squared. Over here, there's not much we can do other than bring the 3 in front. And then we're going to have 4x plus 2 cubed. And we're pretty much done at that point. You could then take this further. You could pull out a common factor. There's a common factor of 3 and also a common factor of 4x plus 2 squared. And then you would need to figure out the factors that would go inside the bracket. So I might just leave that for you guys to check out on your own. But really, we're done at this point. We've used the rule at this point. We've started to tidy up. And then anything beyond that is potentially worth doing, potentially not worth doing. It really depends what ends up in the bracket here. If there's something nice in the bracket there, it might be worth doing that, maybe not. Maybe it's fine just to leave it on that line there. Okay, so it's a slightly different format. So these really common formats, this one different but also common. There's a lot of different formats in which you'll use the product rule. This is also fairly common, but maybe less common than these ones where you've got a product of trigonometric functions, but it doesn't matter. We're still just going to do the same thing. It's in the format to use the product rule. We can go straight into it. So notice, of course, we're using our dy dx notation for these two because the functions were presented as y, whereas the functions here were presented as f, so we used f prime. So same thing, just going to leave the first function alone, so that's going to be sine 2x. We're going to multiply that to the derivative of the second. If you're not familiar with differentiating the trigonometric functions, then they're very straightforward. The derivative of cosine 4x is negative 4 sine 4x. And if you're not familiar with these, then you will come to these at some point fairly soon in differentiation. And then we're just going to leave the second function alone, which is cosine 4x. And we're going to multiply that to the derivative of the first function, which is 2 cosine 2x. Sorry, I'm running out of board space there. So first function just being left alone, derivative of the second one plus the second function being left alone times the derivative of the first one. And there's not a lot of tidying up we can really do here. All we could do is maybe bring this minus 4 in front. So we get minus 4 sine 2x sine 4x. So those cannot be easily combined. And then over here we could maybe bring the 2 in front to get 2 cos 2x cos 4x. So really in this case, for this example, we're just using the rule directly, and then there's not a whole lot of algebra we can do to tidy that one up. But the point is that if we did not know the product rule, then how would we differentiate this? Probably we couldn't differentiate it, or we could maybe use some trigonometric identity, but without the product rule, we don't have the option here to use, for example, the power rule like we could use in these examples, where we could theoretically expand all the brackets and then use the power rule. So the product rule is really common in any course in calculus or differentiation. So if you're taking one of those courses, then learn the rule, the theoretical structure of the rule, but more importantly, learn how to use the rule in different scenarios. It's recognizing when to use the rule and applying that rule in different scenarios that really is the key. So I hope that helps, and any questions or comments about this video, just leave them in the box below.